Eastern Cape, November 2020, grade 10 maths, paper 2. We're now on question 5. Okay, so we're given this parallelogram ABCD, and we are asked to prove that AB is equal to CD and that AD is equal to BC. So we can use all of the qualities of a parallelogram that we know, except the fact that the opposite sides are equal, which is what we're trying to prove. So we know that these sides are parallel. It's given in the diagram. Like so, okay? So we're actually given a hint that we can prove that these triangles, so triangle ABD is congruent to triangle CDB. So we're trying to prove that this triangle is congruent to this triangle, and by that then we can say that this line is equal to that line and this line is equal to that line. So to prove congruency, we can do side angle side, or side angle angle, or angle angle angle. So first we know that this line here is common. So we can say that BD is common. So we have a side. I'm just going to put that here. Then I know that these lines are parallel, which means that I've got this structure here, and that means that this angle here is going to be equal to this angle here because of alternate angles. So I can say that B2 is equal to D1, and my reason is alt angles equal, and I have to say that AB is parallel to DC. And then similarly, I've got that these lines are parallel, and so I've got this structure here, which means that this angle and this angle are going to be equal. So I can then say that B1 is equal to D2, and again, alt angles equal, and this time it's BC that's parallel to AD. So I've now proved that this line is common, and I've got these angles that are equal and these angles that are equal. And so by side angle angle, I can say that this triangle is congruent to this triangle. So therefore, triangle ABD is congruent to triangle CDB, and my reason is side angle angle. And from there, I can then conclude that the opposite sides are equal, because if these triangles are congruent, then that means that this side is equal to this side in length, and this side is equal to this side in length. And so I can say, therefore, AD equals BC, and AB equals DC. Okay, next question, 5.2. I'm given a parallelogram KLMN, and I'm given that angle N is equal to 7x minus 30, and angle L is equal to 5x plus 18. So for the first part, I'm asked to calculate the value of x. So I was told that this is a parallelogram, which means that these are parallel and these are parallel. And in the previous question, we proved that the opposite sides of a parallelogram are equal. So I can say that this is equal in length and this is equal in length. And I know from a parallelogram that the quality of the parallelogram is that opposite angles are equal, which means that this angle MNK is equal to this angle MLK. So I can write that equation. So I'm first going to say that MNK equals MLK LK, and that's because of palm. And then I can substitute the angles that I was given. So I have 5x. Let's write this the other way. So for the MNK one, it's 7x minus 30 is equal to the MLK one, which is 5x plus 18. And I'm going to take my x's over to the left-hand side. So this 5 becomes negative 5. So I'm going to have 2x on this side. And then I'm taking 30 over to the right-hand side. So it becomes positive 30. And I have 18 plus 30, which is 48. And then my x is going to be equal to 24 degrees. Okay, and then the next part is I'm told that LKN, which is this one, is equal to 4y. And now I'm asked to determine the value of y. So remembering that, excuse me, that this shape, MLKN, was a parallelogram, and I've said that these lines are parallel, then these two angles here are co-interior angles, and from our properties of a parallelogram, we know that co-interior angles sum up to 180. So I can take, so LKN plus the other one is MNK equals 180 degrees, and that is coint angles with KL being parallel to MN. And then that means that 4y plus 7x minus 30 is equal to 180. And then remember in the previous question, we just solved for x. So now I can say that 4y plus 7 times x, which is equal to 24, minus 30 is equal to 180. Okay, and then I'm going to take all my constants over to the right-hand side. So on the left-hand side, I'm left with 4y, which is equal to 180 minus comes to 138. And then I can say that y is equal to 10.5 degrees. Okay, and on to question 5.3. So I'm given these shapes, and I'm told that ABCD is a parallelogram. So that's this one is a parallelogram, such that AD is equal to BE. Okay, so I'm going to label that. AD is equal to BE. And I'm told that the angle A is equal to 124 degrees. And that ED bisects BEF. Okay, so then that means that this side of the line and this side of the line's angles are equal. And I'm told that BEFD is a parallelogram. Oh, is a quadrilateral. Right, not a parallelogram, a quadrilateral. And then I'm asked to find the values of x and y, and x is here in the diagram and y is here in the diagram. Okay, so the first thing that I'm going to do is recognize that I've got my parallelogram here, and I've just proved that the opposite sides of a parallelogram are equal. So if this is AD, then that's going to be equal in length to BC, which is also equal in length to BE, because I was given in the question that these two are equal. And I know that this one is equal to this one because of opposite sides of a parallelogram, which means that this one must be equal to this one. Okay, so I'm going to start with BC being equal to AD, and that is upsides palm, and therefore BC is equal to BE. Since BE equals AD, which was given. Okay, and the next thing that I know about my parallelogram is that the opposite angles are equal, which means that this angle A is going to be equal to this angle C. So I'm going to say that angle C is equal to angle A is equal to 124 degrees, and that is because of opposite angles palm. And I'm going to label that on my diagram. 124 degrees. Okay, now I can see that this BCE triangle is an isosceles triangle because I've got the two opposite sides that are equal. And if I can find the size of this angle and the size of this angle, then I'll be able to find the size of this angle. So first I can say that this is on a straight line. So this if this BCD is equal to 124, then this BCE is going to be equal to 180 minus 124. So I'm going to say that BCE is equal to 180 minus 124, and that's angles on a straight line. And that is equal to 56 degrees. And I'm going to put this on my diagram. Now, since these sides are equal, I know that it's an isosceles triangle, and if the sides are equal and it's an isosceles triangle, then it means that the bottom angles are going to be equal. So this 56 is also equal to BEC. Right, so BEC equals BCE equals 56 degrees, and that is angles in isos triangle BCE. Alright, so this is 56. Then I know that x is going to be 180 minus 56 minus 56 because of angles in a triangle. So x is equal to 180 degrees minus the other two angles in the triangle, which are both 56. And that is equal to 34. It's equal to 68. And that is angles in triangle BCE. So we found the value of x. And now to find the value of y, remember that we were told that this angle here had been bisected. This angle E was bisected. So if on this side of the line the angle is 56, then that means that on this side of the line the angle is also 56. So we can say that DEF is equal to 56. So DEF equals 56 degrees. And we can say bisected angle E. And it's labeled in the diagram that this is 90 degrees. And so from angles in a triangle, I know that y is going to be 180 minus the one angle minus the other angle. Therefore, y is equal to 180 degrees minus 90 degrees minus 56 degrees, which is equal to 34 degrees. And that is from angles in triangle DEF. Alright, so for question 5.4, I'm given this shape and I'm told the length of all these sides. And the first question is prove that triangle EFT, which is that one, is similar to triangle DCT, which is that one. So I want to prove that these are similar. So what I'm going to do is look at the length of the sides. So I've got 9 and 18 for this bottom part. I've got 10 and 5 for the one side. And I've got 7 and 14 for the other side. And if you notice, 9 is half of 18, 7 is half of 14, and 5 is half of 10. So we can see that these triangles are already in proportion. So I'm going to write that dt over et is equal to dc over ef, which is also equal to tc over ft, which is equal to a half. Right, so I've just matched up all the triangles with each other. I mean the sides of the triangles with each other. So this is the EF, this is the ET and the DT, and then this is the DC and the EF, and then this is the FT and the TC. Right, so I can say that all of these ratios are equal to a half. And therefore, the triangles are similar. So triangle EFT is similar to triangle DTC. And my reason is going to be sides in proportion. Then for the next part, it says that we are further given that DFC it's further given that DFC, which is DFC is this angle, is equal to TDC, which is this one, and they want us to prove that FEC is equal to TFC. Okay, so from the congruency of the triangles, the similarity of the triangles, so if these are similar, then we can say that FEC is equal to TDC. So FEC equals TDC, and that's from similar triangles. And we're told in the question that DFC is equal to TDC, right, that these two are equal. So DFC is equal to TDC given. Then we can clearly see that EFC is equal to TDC as well. Sorry, FEC is equal to TDE. Is equal to TFC. Okay, and now on to the final part of question 5. We're given this triangle DEF and we're told some information. So the first thing that we're told is that DS is equal to SE, and we're told that EU is equal to UF, and we're told that ST is parallel to EF. Yep. Okay, so the first thing to notice is that this U, the point U and the point S are midpoints. And if we have midpoints and we have a triangle, then we can use the midpoint theorem. So the midpoint theorem says that if you draw a line in between any two midpoints on a triangle, then it's going to be parallel on two sides of a triangle, then that line is going to be parallel to the third side of the triangle. So I've got this midpoint S, and I've got a line that is going to a point on the other side of the triangle, so it's going to T. And I was told that this line is parallel to this line, which is the third line of the triangle. So from that, I can conclude that T is also a midpoint. Midpoint. Right, so if T is a midpoint, then this DT is equal to TF. Then from there, I've got this other midpoint U. I was told in the question that these two sides are equal in length, so U must be the midpoint of EF. And I've now found that T is the midpoint of this DF. Now I've got the midpoint of one line of a triangle, and I've got the midpoint of another line on the triangle, and I've got this line that's joining them. So from the midpoint theorem, that would mean that the line joining these two midpoints and the third line of the triangle are parallel. Right, so I've got that this side here is parallel to this line here that's joining the two midpoints. And if this whole side of the triangle is parallel to this line, then that means that just this SE part is also parallel to the UT. So I've got parallel, parallel. I was told in the question that this ST is parallel to EU, which means that I've got these two sides of the shape being parallel and these two sides of the shape being parallel, and those are exactly the qualities that I need for a shape to be a parallelogram. So from that I can prove that this STUE is indeed a parallelogram. So we can write down the proof here. So the first thing that I noticed was that T was the midpoint. Or, well, let's start with saying that ST is parallel to EF, which I was given. So if ST is parallel to EF, that was given, then that means that T is the midpoint. So if T is the midpoint, then DT is equal to TF. So DT is equal to TF. And for this reason, I'm going to write the converse of the midpoint theory. And the reason why I'm writing converse midpoint theorem is because I'm using the midpoint theorem in reverse. Right, because the midpoint theorem says that if I was given these two midpoints on the sides of the triangle and there's a line in between, then I can conclude that this line is going to be parallel to this line, the third line of the triangle. But what we did is that we already had one midpoint and we were told that these two are parallel. So then we conclude that T is also a midpoint. So it's just using the midpoint theorem in the opposite direction. Okay, and then moving on, so now that we've got that DT is equal to TF, then I've now got that T is another midpoint in my triangle, and I was told in the question that U is a midpoint because they said that EU is equal in length to UF. So again, converse midpoint theorem, I've got two midpoints, and I've got this third line here of the triangle. So that means that the line joining these two midpoints is also going to be parallel to this whole line of the triangle. And if it's parallel to the whole of DE, then it's also parallel to the whole of SE. Okay, so then I'm going to go ahead and say that UT is parallel to SE. It's parallel to the whole DE, but I'm just going to say SE because that's the parallelogram that I'm trying to prove. And that's again by the converse midpoint. And now I've got this STUE, and I've got two opposite parallel sides, and that's all I need for a parallelogram. So I can conclude that therefore SEUT is palm, and my reason is two upsides parallel.